Upbeat, intriguing music starts and fades slightly to the background. Hey everyone, and welcome back to the channel. Today, we're taking a deep dive, literally, into one of the most incredible engineering feats of the ancient world. Forget smartphones and supercomputers for a second, because we're re-talking about something that powered an empire and is still mind-blowing today. The water systems of ancient Rome. Think about it. Rome was a bustling metropolis, the New York or Tokyo of its time, with over 1 million people. How did they all get clean water for drinking, bathing, and, flushing those famous Roman latrines? The answer lies in a network of structures that were so advanced, they feel like they were built thousands of years ahead of their time. And no, it wasn't just about throwing a few pipes in the ground. We're talking about the legendary aqueducts. These weren't just beautiful stone bridges crisscrossing the landscape. They were monumental water highways. Some of them stretched for over 50 miles, or 80 kilometers, bringing fresh water from distant springs and mountains right into the heart of the city. Now here's the truly genius part. How did they get the water to flow over such long distances without modern pumps? It was all about gravity. Roman engineers were masters of precision. They calculated the gradient, or the slope, with incredible accuracy. We're talking a drop of just a few inches for every 100 feet. That's like tilting a football field by just the width of your hand. This gentle, consistent slope was the secret sauce. It kept the water flowing steadily without it going too fast and eroding the channels, or too slow and stagnating. It was a perfect, delicate balance maintained over dozens of miles. Building these aqueducts was a massive undertaking. Surveyors, using simple tools like a asterisk corbits, which was essentially a sophisticated level wood map out the terrain. They had to decide whether to build on arches, tunnel through mountains, or create pressurized siphons to cross valleys. Yes! You heard that right! Siphons! They would use lead pipes to force water down one side of a valley and up the other, a principle of physics that still wows engineers today. It was a colossal puzzle of logistics, labor, and pure mathematical genius. Once the water arrived in Rome, the story doesn't end. It entered massive distribution centers called castera aquae. Think of these as ancient water towers. From here, a complex network of lead and bronze pipes branched out across the city. This is where the social engineering comes in. The water wasn't just for everyone equally. The system was hierarchical. The imperial palace and the wealthy got first dibs with their own private connections. What was left over went to the public amenities. The grand public baths, or thermi, and the hundreds of public fountains that provided free, clean water for the general population. These public fountains were the lifeblood of the city for ordinary Romans. Imagine not having a tap in your apartment block. You'd go to the local fountain every day to collect water for cooking, cleaning, and drinking. It was a social hub, a place to catch up on gossip, a fundamental part of daily life. And let's talk about the baths! The Roman baths were more than just a place to get clean. They were like modern-day community centers, gyms, and spas all rolled into one. They had hot pools, cold pools, steam rooms, libraries, and gardens. And all of this was powered by the constant, reliable flow of water from the aqueduct. The scale is staggering. The baths of Diocletian, for example, could accommodate thousands of people at once. This culture of public hygiene, made possible by their water system, was unparalleled in the ancient world and contributed significantly to public health. Of course, with all this water coming in, you need a way to get the wastewater out. Enter the cloaca maxima, or greatest sewer. This was one of Rome's earliest engineering marvels. Originally, an open drain that was later covered. It collected wastewater from the streets, the latrines, and the baths, and funneled it all into the Tiber River, carrying it away from the city. This integrated system of bringing fresh water in and taking wastewater out was revolutionary and crucial for the city as sanitation. But what about maintenance? A system this vast needed constant upkeep. The Romans had a dedicated workforce, the cura aquarum responsible for patrolling the aqueducts, clearing out mineral deposits, and repairing any leaks or damage. They even had access shafts so workers could go inside the channels to clean them. It was a full-time, highly organized operation, ensuring the water kept flowing day and night. The legacy of this system is truly astounding. When the Western Roman Empire fell, much of this knowledge was lost. For centuries, European cities couldn't even dream of providing water on the same scale as ancient Rome, but the structures themselves endured. Many Roman aqueducts, like the Ponte du Gard in France or the aqueduct of Segovia in Spain, are still standing today, almost 2,000 years later. They are powerful, beautiful testaments to the skill and vision of their creators. Some were even used for centuries after the fall of Rome, and in a few incredible cases, parts of the ancient systems have been integrated into modern water networks. So, the next time you turn on a tap, take a moment to appreciate the journey that water takes. And remember the ancient Romans who, with little more than ingenuity, stone, and an incredible understanding of gravity, engineered a system that supplied a massive city with life-giving water, shaping a civilization and leaving behind a legacy that continues to inspire us today. They truly were engineering giants, living thousands of years ahead of their time. Thanks so much for watching. If you found this as fascinating as I did, don't forget to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next journey into the past. Let me know in the comments which ancient engineering feat you want to see next. Until then, stay curious.